A manufacturer claims that the mean lifetime of its fluorescent bulb is 1500 hours. A homeowner randomly selects 40 bulbs and finds the mean life to be 1480 hours, 1480 hours. With a population standard deviation of 80 hours, test the manufacturer's claim. Use alpha equals to 5% or 0.05. So in this example, we are asked to perform a hypothesis test for one population mean when the population standard deviation is known. And what we are going to do, we are going to apply p-value approach, p-value method, right? And recall from my earlier video, there are 5 steps for performing this hypothesis test. So what we are going to do, we are going to test these steps. We're going to perform these steps one by one. Let's see what is the step number 1. So in the step 1, what we do, we check the basic requirements. So step number 1, we check basic requirements. And what was the basic requirement? Number 1, we need to have a random sample. And number 2 was either the sample size is greater than or equal to 30 or the population is normally distributed. I hope you remember these steps. Let's check these requirements one by one. Where's the first one? Random sample. Look at that. Homeowner randomly selects. Randomly. So we have a random sample, right? And what is the sample size? The sample size is 40. Our sample size is 40 and definitely 40 is greater than 30. So this requirement is also met. So the basic requirements are met. We don't have any problem with the basic requirement. So our first step is okay. Now what we do now? We go to the step number 2. See the step number 2. In step number 2, what we do, we write the null hypothesis, we write the alternative hypothesis, we decide what type of test it is, and we write the significance level. Okay, so let's read the statement. Let's read the claim. What is the claim? The claim. The manufacturer is claiming that the mean lifetime of these bulbs is 1500 hours. So the mean is equal to 1500 hours. So what is the opposite of that claim? What is the opposite of that claim? What is the opposite will be mean is not equal to 1500. I hope you remember, if we have an equal sign, its opposite is not equal sign. I hope you remember that. I told you earlier also. Now recall that a null hypothesis is always a statement of equality. And a null hypothesis never contains a not equal symbol, never. So it means this first statement is our null hypothesis. Mu is equal to 1500. This is our null hypothesis. And if the first one is our null hypothesis, definitely the second one will be our alternative hypothesis. It's not equal to 1500. So we have found the null hypothesis, we have found the alternative hypothesis. Now what we are going to do, we are going to decide what type of test it is. So you see, as the type of a test is always decided by the alternative hypothesis. Remember that. As the alternative hypothesis contain a not equal symbol, so it's going to be a two-tailed test. So you're going to say, note that as alternative hypothesis contains a not equal symbol, it implies it's a two-tailed test. It's a two-tailed test. And finally, in this step, we write the significance level. The significance level is given to us is a 5%. Alpha is 5%. It's 0.05. So we have completed the step number 2. We have write We have written the null hypothesis, we have written the alternative hypothesis, we have decided the type of a test, the two-tailed test it is, and we have written the significance level. Now we go to step number 3. In the third step, we find the value of test statistic. And fortunately, we have the formula for that. The formula is Z equals to, I call this as a test statistic, Z sub test, which is indicating this is a test statistic. It has a formula x bar minus mu divided by sigma over the square root of the sample size. Now we have all these values, we can plug in and we can compute the value, the standardized test statistic, right? Let's see what are the values. The sample mean is 1480. So it's a 1480 minus mu is 1500. The standard deviation sigma was 80 hours. If you see, look at that, 80 hours in red written. It's 80 divided by the square root of the sample size. The square root of the sample size. What is the sample size? It's 40. 40. That's the square root of the sample size, right? 1480 minus 1500, it's minus 20 multiplied by, keep it, change it, flip it. This is 40 to make our life little easier, divide by 80. Just I have done a simple math, simple fraction manipulation, right? Keep it, change it and flip it. That's what I have done. So what I'm going to do now, I'm going to plug these values in the calculator and I will find the value of the test statistics, and the value is minus 1.58 rounded to the 2 decimal places, right? So this is the value of the test statistics. This value will help us in deciding this hypothesis test, right? After finding the p-value. So now we move to the step number 4, and in the step number 4, what we do, we find the p-value, right? So let's write a step number 4. Step number 4, and what we do in the step number 4, we find the p-value. So in order to find the p-value, what I have done, I have drawn a normal curve, right? Exactly in the middle, I have taken the mean value. And now what I'm going to do, I'm going to locate this value of the test statistic in this figure, right? In this normal curve. Minus 1.58 will be somewhere here. Minus 1.58. Once you have located this value, you will do that. We'll draw this boundary line, right? And this area, the twice of this, the double of this area will be our p-value. Remember that finding the p-value in a two-tailed test is little involved, and you have to be very you have to pay attention on that, right? So this is the area that is the left of the test statistic. This is minus 1.58, right? So in this case, as it's a two-tailed test, my p-value will be equal to 2 times this area. 2 times this area. What I will do, I will find the area to the left of the minus 1.58 and I multiply by 2. Why I am multiplying by 2? Because it's a two-tailed test. And recall from my earlier video, if it's a two-tailed test, you always double the area. If the value of the test statistics is to the left of the center, this was my center, it's on the left side. What we do, find the area to the left of the test statistic and we double that area. And what I'm going to do, I'm going to use Microsoft Excel for this purpose. Let's see how I'm going to do that. So instead of using Microsoft Excel, I thought it's a good idea to share with you how I can find this value by using a table. In my previous example, I have used Excel. So let's do this via table. So what I have done here, first I will find the area to the left of this test statistics, which is minus 1.58. For this purpose, I will go to my table. Let's go to the table. This is on the extreme left column. My value happens to be the z-score was equal to the z-score. Let's recall what was my z-score. My z-score was equal to z was equal to minus 1.58. So what I have done on the extreme left column, I have this minus 1.5 here and 0.08 here, and at the intersection of these two values, the value is 0.0571, 0.0571, and this is exactly the value I'm writing here, 0.0571. And don't forget to double this area. I have doubled this area. Once I double this area, I get the value, the p-value. My p-value comes out to be 0.1142. If you find this value by using technology, you may get little different value, a very slight difference. Why? Because the technology gives a more accurate calculation, whereas the table have a rounded calculation. So there will be a little discrepancy, very small discrepancy on a hand computation value and a technology, the value that comes out from technology. Now this was the step number 4. Now we go to the step number 5. So in step number 5, what we do, we compare a p-value with the significance level, and then we decide the hypothesis test. Let's write the p-value. My p-value was equal to 0.1142, and let's write the value of alpha. Alpha was equal to 0.05, right? Let's compare these two values. Let's compare these two values one by one. 0, 0, 1 and a 0. So definitely this value, p-value, is larger than the alpha. So what will this imply? This implies that p-value, our p-value, let me correct that. Our p-value, this implies that our p-value is larger than alpha. If p-value is higher than the alpha, then H naught must fly. You remember that that little word to remember? If the p-value is greater than alpha, we fail to reject the null hypothesis. So you say as p-value is greater than alpha, it implies that we fail to reject H sub 0, and as a result we fail to support alternative hypothesis. We fail to support H sub a. So I told you, if the p-value is greater than alpha, then we fail to reject the null hypothesis, and as a result we fail to support the alternative hypothesis. Now I will show you a technology that's called Microsoft Excel and not Microsoft Excel, but rather StatCrunch, and I'm going to show you how I'm going to get the same answer by using StatCrunch. Let's go to the StatCrunch. So I already launched the StatCrunch, and you go to Stat and you go to ZStat, one sample with summary, with data, or with summary. We don't have a raw data, we have a summary. To go to the summary, right? Now he's asking, do you want to perform hypothesis test? Yes, we want to perform a hypothesis test here. We want to perform a hypothesis test. He's asking, what is the sample mean? Our sample mean was 1480. Our standard deviation was 80, and the sample size was 40, and our null hypothesis was 1500, right? And this is our null hypothesis, and this is our alternative hypothesis. By default, he's showing you the value not equal. It's a two-tailed test, but you can change it if you want. If it was a different one, you can have a left-tailed test, you can have a right-tailed test, but right now we have a two-tailed test, and we are working with a 95% confidence interval, and the alpha value is 5%. And now you click on this one. Do you want to find the p-value plot? Yes, I want this p-value plot. Now you hit compute. Now once you hit the compute, look at that. This is our z-stats, right? This is our test statistics minus 1.58, and this is our p-value. I told you in a technology you will get little different. My answer was 0.1142, something like this, but this is a different one, right? Now look at this plot. Look at this two-tail test. Look at this two-tail test. Both the tails are shown here, and these are the, I will tell you the rejection region. Clearly, you have the z-stats and you have the p-value. Now, you can see that as the p-value is greater than alpha, so we fail to reject the null hypothesis, and as a result, we fail to support the alternative hypothesis. And it's the same result we get by hand computation. I hope you understand this example. Thanks for watching.